In calculus, we learned about the derivatives of displacement, which are velocity and acceleration. Velocity is the rate of change in displacement over time, and acceleration is how fast velocity changes. Cut. Look at this ball. Right now it's at rest, it's not moving. That means its displacement is zero, because it hasn't moved, its velocity is zero, and its acceleration is also zero. Now when I drop it, its displacement changed because now it's down here. That means its velocity was positive for a time because it was traveling down. The velocity changed from zero to something. That must mean there was a change in acceleration because there was a change in velocity. So because acceleration increased from zero to something, that must mean there was a change in acceleration, and we call that jerk. Jerk is the third derivative of displacement, but because jerk changed, the derivative after that must have also changed, and so on and so on. Essentially, all the infinite derivatives of displacement have changed in the moment I drop the ball. We don't have names for all of them, and we rarely use most of them in real life, but here are the names of the first 10. They're velocity, acceleration, jerk, jounce, flounce, and pounce, also known as snap, crackle, and pop, lock, drop, shot, and put. As I said, most of these aren't very useful to us, but we're going to look at jerk and some of its applications in real life. Jerk is the change in acceleration over time, and it's also proportional to the change in force over time when dealing with a given mass. Let's look at a car as an example. When you're starting up a car, the car moving forward is velocity, because it just has speed, it's moving forward. When you press down on the gas pedal, that's acceleration. How far you press down is how much acceleration you have. If you press down a little bit, the car is going to accelerate fairly slowly. But if you press down all the way and floor it, the car is going to accelerate very, very quickly and reach higher velocity very quickly. Now, jerk is how fast you press down the gas pedal. If you just immediately floor it all the way, you're going to have a very high jerk and reach a higher acceleration very, very quickly. But if you slowly increase how much you press down on the pedal, then you're going to have a less jerky ride, essentially, because you're going to accelerate more smoothly. Another instance in which it's very important to limit jerk is roller coasters. If you have a high jerk, and therefore the force and acceleration are changing very, very quickly, it may cause whiplash, which you really don't want for your riders. And just for fun, here's a graph of the first 5 derivatives of displacement.
But of course, this video isn't just talking about derivatives, it is also talking about integrals. For example, what happens when you take the integral of displacement with respect to time? You get a quantity known as absolute, measured in meters seconds. But wait, there's more. If we keep going and taking the integral of absolute, we get the following. Absity, acceleration, absurd, absnap, absackle, absop. Well, you get the idea. But what does this tell us? Well, you could use absolute, for example, when you go off to college, to measure how far away you are from where you started and for how long, also known as meter seconds. That would be one way to use absolute. The coolest way to use absolute is through a musical instrument known as a hydraulophone. Hydraulophones use water flow to produce certain pitches. By pressing a key or a hole will result in more water buildup, which will produce a different sound. This is different from a piano, which uses how hard you strike a key to determine how loud it is, so it uses velocity of the finger rather than where the finger is placed. Hydraulophones use how long a key is pressed to determine what the note is, which is an application of absolute, how long your finger has been displaced for. Another use of absolute is communications theory, which states that the farther you are and the longer you talk through a phone or another communications device, the harder it becomes. This is measured through meter seconds, otherwise known as absolute. Thank you for watching Roy and Tim's presentation, and